As of this moment, you should know everything about arithmetic sequences and series, right? Actually, let's go back to section 10.1. 10.1, you learn to identify the difference between the arithmetic sequence and a geometric sequence. The difference between an arithmetic sequence or a geometric sequence is that arithmetic have a common difference d and geometric have a common ratio r, okay? Then we also learned about the a sub nth rule of an arithmetic sequence. And any sequence, your first number is considered your a sub 1 term. So we're going to begin the formula for the a sub nth rule of an arithmetic sequence with a sub 1. There is a plus sign right here, and that makes total sense because from your first number to get to your next number, you're going to have to add that common difference, right? And over here, just more recently, we learned about the geometric sequence a sub nth rule. And right here, you start with your first term, a sub 1, but you multiply by the common ratio. When I do this formula, I like to put the r in parentheses. I don't know if you like that or not, but I like to put the r in parentheses. Anyway, so up until now, we know the arithmetic sequence and geometric sequence, the a sub nth rules of each. We also are supposed to be very good at the summation formula of any arithmetic sequence, which is used on series. A series is simply your arithmetic list, but added up, right? So we're able to find the summation of however many numbers you have on the list. And how do we do that? Out here, you have the number of numbers on your list. You have your first term, your last term. You divide it by 2. Do all that math on a calculator. It'll give you the summation of any arithmetic series. Today, we're going to focus in on geometric series. We already did the a sub nth rule of geometric sequences. Today, we're going to be copying down these formulas for geometric series. I want to pause it right now. You guys copy it down, and then we'll continue. So I have decided to leave these available to you on the next assessment. That way you don't have to really worry about memorizing, but you got to know which formula you're going to be using on what situation. So let's I want to cut this out, and I'm going to move down here to a couple of examples on how to use this formula for summation of a geometric series. So we have your two different types of summations. We have the sigma notation. This one's interesting because it starts at 3 instead of 1. And we also have your traditional summation of that geometric series, right? You have 512 plus 256 plus 128 plus so on and so on until you get to the number 1. So which one would you guys like to see first? Sigma 1? Okay, so let's take a look at the sigma 1. And we have our formula right here on the side, or our formulas. We'll see which one we use. But even before looking at the formulas, how about this? Let's just take down whatever information we can based off of this. Do we know the common ratio from this? And if you're like, well, I don't know, I don't see a common ratio, you actually can see the common ratio. Because if we know what the a sub nth rule of a geometric sequence is, so here's my a sub nth rule of a geometric sequence. Notice that this is in the form of the geometric sequence, the a sub nth rule, right? If you were to have started at 1, then this number right here will be your first term, your a sub 1. The base of whatever exponent situation you have, that base in parentheses is your r, your common ratio. Okay, so you need to know, first of all, that by looking at this, you're looking at a geometric series, not an arithmetic series. What would an arithmetic series look like? Something simple like 2k minus 1, right? Or k plus 3, or 5k take away 7. That would be arithmetic. But right here we have the base, which is technically the common ratio. We have the exponent, which normally is n minus 1, but we have k minus 1 instead because we're talking about the variable k instead of n. And that number out here in the front, the 4, that's technically your a sub 1 term, if we actually started with the number 1. But on this one, they want us to start with the number 3. So again, let's write down what we know. We know for sure that the common ratio is 2. We also know, well, it could be tricky. The first term is technically 4. However, the first term on this particular series is plugging in 3 and working it out. So let me actually plug in 3. I have 4 times 2 to the 3 minus 1. That's really 4 times 2 squared. That's 4 times 4, which is 16. So in this case, our first number, which I normally call a sub n, but I don't want to confuse anybody right now, right? First number is 16. Normally I call it a sub 1. I'm sorry, not a sub n. A sub 1 is normally 16, but I'm just going to write first number, that's 16. So what else do we know? Could we find our last number? How do we find the last number? Plugging in the 10, that's right. So if I take the 10, plug it in right there, we're going to need a calculator. Somebody help me out, yeah? I'm going to have, I'm going to keep my work separate right here. I'm going to have 4 times 2. 10 minus 1 is 9. So with the calculator, we need to do 2 to the 9th power. And we will have 4 times whatever that huge number is. Anybody have it? 512. Thank you very much. And what is 4 times 512? 2048. Okay, so this is our last number, 2048. That's the last number. Anything else that we need? I guess not. Okay, so now let's go up to our summation formula. We could use the first one, a sub 1 minus a sub 1 times r to the n. Oh no, we need n. How many numbers actually are there right here when you start on 3 and stop at 10? There's 8, right? Again, you think 10 take away 3 plus 1. 10 take away 3 is 7 plus 1 is 8, so there's a total of 8 numbers. So we could easily use the top one or the bottom one. It's totally up to you guys. What do you prefer? Let's go with top. All right, so the top one, let me bring this over here. Wow, this is getting ugly. We're going to use the top formula. On the top formula, we have a fraction, minus, we have 1. And the a sub 1 term, our first term, which is technically the a sub 3 term, is 16. So we're going to put 16 up here. And then minus a sub 1 again, minus 16 again, times the common ratio 2 to the n power. And we said n is 8, so you put an 8 up there. And on the bottom, we have 1 minus the common ratio, right? 1 minus the common ratio. So again, the common ratio is 2. So that's 1 minus 2 down here. So we're going to do some math. We're going to begin with 2 to the 8th with the calculator. 2 to the 8th power is 256. And I am going to take, with the calculator, 256 times 16. 256 times 16 is 4,096. So what I really have is 16 minus 4,096 divided by, I might as well do 1 take away 2, that's negative 1. So if I do 16 take away 4,096, we'll get negative 4,080. Negative 4,080 up on top over negative 1, which would give you your final positive answer. The summation, I'll write it in red, the summation of these 8 numbers is equal to 4,080. So on the quiz, I'd give you something like this, and you would have to type in 4,080, and that's it. Yes, question? Let's take a look at this other example over here. Get this out of the way. Oops. Get this out of the way. So this other example, we have a series. It's not arithmetic. By the way, you got to check if it's arithmetic or geometric to know which formula you're actually using, right? If you actually saw a common difference, this one take away that one is the same thing as this one take away that one, then you'd be using the summation formula of arithmetic. But right here, 128 take away 256 is definitely not the same as 256 take away 512. So then you try common ratio, 128 divided by 256, and then 256 divided by 512. So that does give you the common ratio of what? 1/2. That's exactly right. So let's write that down. R equals 1/2. We know that for a fact. Again, we just took a number, divided it by the previous. Even if you did it on a calculator, you get 0.5. That's your common ratio, 0.5. We also know the first term, a sub 1, is 512. So we know a sub 1 is 512. We also know our last term, a sub n. A sub n equals 1. Okay, so we have this bit of information. Now, if you tried to use the top formula again, let me zoom in on that. If we try to use this top formula again, yeah, you have your a sub 1 term, you have your a sub 1 term, you do have your r, but you don't know how many numbers there are, right? So you have an n up there, that messes it up. If it were in sigma notation, yeah, you could do the top one minus the bottom one plus 1, that'll give you the n. Right here, we don't know what n is. So this is not a good formula to use in this situation. I mean, you could find n by using the a sub nth rule, but that's a really long process. Why not use the bottom one? Because the bottom one, you have your first term, you have your a sub nth term, your last term. So you take that 512, put it right there, take the 1, put it right there, and you already know your common ratio, which is 1/2. So you have everything you need for the bottom one. So this is a good example of not using the top one, but actually using the bottom one. Yeah? All right. So let's actually use that bottom one. And the bottom one reads S sub n, I don't know how many terms there are, equals a sub 1, that's 512, minus a sub n. A sub n is 1, so I'm going to put minus 1, and then times r. R is 1/2, so times r, that's 1/2. That is over 1 minus r, which is 1/2. Okay, so up on top, it's pretty easy to do. 1 times half is 1/2. 512 take away half, $512 take away 50 cents is $511.50. So 511.5. And it's being divided by 1 take away 2, that's really 0.5 or 1/2 also, right? Now, if you don't have a calculator, this is what you're going to have to do. You're going to have to take that 511.5 and write the division of 1/2 like this. But of course, if you have a calculator, you could just type it in and get your final answer. But whenever you divide by a fraction, you don't mess with the first term, but the second one, you change to multiplication and you flip the second fraction. The 1/2 becomes 2 over 1. So the problem that you really have right here is 511.5 times 2, and that will be 1,023. So this is your summation answer to that summation problem. Okay, so let's jump to, so this is a optional practice, but I highly recommend it. It's pretty simple, straightforward. This middle part right here, 7 through 13, it says write an equation for the nth term of each geometric sequence. So what is the a sub nth rule? It's a sub n equals a sub 1, common ratio r to the n minus 1 power. So our a sub 1 is what? 3. So you have a 3 in place of the a sub 1. What's our common ratio? It's 3 also. And of course you have the power of n minus 1. And that is your a sub nth rule. That's simple. That is the answer to number 7. I think I assigned the even ones 2 through 22. But let's go to the first part of this homework. This is pretty easy as well. Right here they want you to find a sub n, which is the last number of your sequence, of your geometric sequence. So let's begin with the a sub nth rule. The a sub nth rule is a sub n equals a sub 1 times the common ratio r to the n minus 1 power. A sub 1 is 5, common ratio is 2 to the n minus 1 power. That's your a sub n rule. They want us to specifically find the last number, the 6th number. All right, the 6th number on this list. So that would be simply plugging in 6. The notation for that would be to put a sub 6. That's not really any math. It's just the notation for the math that we're going to be doing. And we're going to have 5 times 2 to the 6 minus 1 power. So you really have 5 times 2 to the 5th power. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So what you really have is 5 times 32, which is 160. So there's your a sub nth term, your last term, 160. Bless you. So again, on the quiz or test, I could give you this information, and I'm going to ask you to just type in the answer 160, right? When I ask you find a sub n, for this information. A sub n would be 160. Last but not least, so the last part of the worksheet, that's kind of interesting. Maybe stop at 22 if you want, unless you want to try more. I want to do 21 right now with you. It's kind of more challenging because they're not asking you, they're asking you for the first term of the list of this series. And it is geometric. They tell you that. They give you the common ratio. They actually tell you how many numbers there are in the list. And they tell you the last number is 1,295. Actually, no, not the last number. It's not A sub n, it's S sub n. They give you the summation. So we know we're going to be using the summation formulas. So we have our summation formulas right here. And the question is, which one should we use? Well, we know we're going to put 1,295 in place of S sub n. We don't have an A sub 1 term, do we? And we don't have an A sub n term. All right, so let's use this top one. Let's see what happens. Let's see where we go. So we know that S sub n is 1,295. That should equal, right? 1,295 should equal a fraction. And in that fraction, we have A sub 1, which we don't know what it is, minus A sub 1 times r to the n. A sub 1 times r to the n. So we're going to put times 6 to the 4th power. So let's first figure that out. 6 to the 4th power on a calculator is 1,296. So this right here, 6 to the 4th, is 1,296 on a calculator. So in reality, what I really have here is I have one of these guys minus 1,296 of these guys. Does that make sense? So what's my answer going to be? Actually, let me write that down so you guys could see. I did 6 to the 4th on the calculator, and that's 1,296. So I really have one of these guys minus 1,296 of these guys. So the answer on top, on the bottom we still have 1 minus r, 1 minus 6. But the answer up on top will be negative 1,295 of those A sub 1 terms. Does that make sense to everybody? No? Okay, that's because I did the work in my head. Check it out. If I were to do this math over here on the side, I have one of these A sub 1s minus, when you multiply A sub 1 times 1,296, you're going to get 1,296 of those A sub 1s. So this is pre-algebra stuff, combining like terms. 1 take away 1,296. You have $1, you owe somebody $1,296. How do you end up? You still owe $1,295. But in this case, not dollars, it's A sub 1s. Do you get it now? Okay. Now on the bottom, we do have a divided by negative 5. Okay? And this does equal 1,295. So let's solve by multiplying both sides by negative 5. That'll cancel out. Multiply by negative 5 on the calculator. 1,295 times negative 5. That equals negative 6,475 equals negative 1,295 A sub 1. And if you want to get rid of the multiplication of that negative 1,295 in front of the A sub 1, divide by the negative 1,295. What you do to one side, do to the other. Divide by 1,295. And I'm doing that on the calculator right now as we speak. 1,295. That's going to give us a nice, beautiful answer, 5. Believe it or not. So we get 5 equals A sub 1. And that's what they were asking for. Find A sub 1. A sub 1 equals 5. So with that said, there's a lot more to practice on this worksheet, right? I highly recommend that you guys do practice, because the only way to get good at this is practice, right? You could totally understand what I'm explaining right now, but if you don't practice, you're not going to do well in the next quiz, right? You got to practice. So let's take the rest of this class to work on this. And of course, on Google Classroom, we have our solutions. Right there's the one we just did. The answer is 5. But we have all our solutions on Google Classroom. Anyway, good luck. Ask me questions if you need help.